All right, so in this P6 and P7 section 6, we're going to talk about a complex number, or really just review. And then 7 is a little bit new, so I'm going to show you how to use the graphing calculator to find some answers. All right, so P6. So first we're going to review some complex numbers. So complex number, if you remember, is in the form of a plus bi, where I is that imaginary part. So refresher, I is square root of -1. So we can't square root a negative number, so we change that square root of -1 to I, so we can do some calculation. So then I squared just means there are two of these multiplied together, so then we end up with -1. So then you just have to remember these definitions. I is square root of -1, I squared is -1. So then let's practice really quickly. So go ahead and pause your video and try these problems. All right, did you get these right? So the first one, I root 5. Now you might say, can I write it as root 5i? Yes, you can. So the order doesn't matter because it's multiplied, but it's just that if you do put it as square root 5 times I, be careful not to accidentally put the square root over I, because that's something very different. And then this one here, just be careful. A lot of people make this mistake. So this is I times basically 3i, and then I times I is -1, so then you end up with -3. All right, so let's look at some properties of complex numbers. First, adding and subtracting is very easy. Just think of it as if you're combining like terms where I is like x. So 7 plus 4, that's the a part of a plus bi, so this is 11. And then the -3 plus 5i, so then we have 2i. Additive identity just means what do I add to the complex number so I end up with 0. So that's pretty easy. It's just going to be the opposite. Multiplying is also very easy. You just think of this complex number as if it's a binomial. So then you can just use FOIL. So 2 times 5 is 10. 2 times -i is -2i. 3i times 5 is plus 15i. And then the last thing is 3i times -i is -3i squared. I'm going to write it as -3i squared for now because I just wanted to make sure I don't make a mistake. You can obviously take shortcuts later, but I'm just going to not do that for now. All right, so let's combine like terms. So 10 plus 13i. And then we have this -3i squared. We know that I squared is -1. So then that becomes -3 times -1. So that is a plus 3. So then combine like terms again, 13 plus 13i. Dividing. The rule is that we cannot have a complex number in the denominator, so we need to get rid of that. And to get rid of that, we need to multiply by something. And we learned this in Algebra 2. It is called the complex conjugate. And we saw this word a lot in Algebra 2, conjugate. Conjugate means kind of the opposite. And so in this case, we are looking for the complex conjugate because it's the conjugate for the complex number. So what is that? If our complex number is a plus bi, then the complex conjugate is a minus bi, where we just change the sign in between the two terms into the opposite sign. So for example, if I have a 2 plus 3i, the complex conjugate would be 2 minus 3i. Then what is the complex conjugate of -5 minus I? That is -5 plus I. So remember, we only change the sign between the two terms. We don't change the sign on -5. What about this last one? 5i minus 4. What is the complex conjugate? Now you might say 5i plus 4. Well, in reality, it does work, but that is not quite the complex conjugate definition according to what we were talking about, because 5i minus 4 is not in the a plus bi form. So a plus bi form is this one. So then the complex conjugate would be minus 4 minus 5i. But for what we use complex conjugate for, it really doesn't matter. As long as we change the sign in between the two terms, you will get the same answer anyways. So we're not super strict, I guess, in using that. Anyways, so let's come back here. So if we want to get rid of this complex number in the denominator, we have to multiply by the complex conjugate, which is 2 minus 3i. And the reason we do that is that this is a 1. We can only multiply a 1 to a expression. All right, so now in the numerator, we FOIL. We get 6 minus 9i. In the denominator, we need to remember our property in Algebra 2. That is a plus b times a minus b. Right? 2 plus 3i and 2 minus 3i is the same idea as a plus b and a minus b. So then what we can do is just remember that this becomes a squared minus b squared. Okay, so this is very important to remember because this will help your math a lot this whole year. So make sure you remember that. So then how do we apply that? Well, think of 2 as a, think of 3i as b. So then if we multiply that together, we get a squared minus b squared. All right, so let's simplify that. 6 minus 9i in the numerator, and then in the denominator, that is 4 minus 9i squared. Okay, so that's much simpler than you trying to FOIL again. Okay, in the denominator, we have a 4 minus 9i squared. We know that I squared is -1. So -9 times -1 is +9. So this becomes 6 minus 9i over 4 plus 9, which is 13. Now you may ask, is this in the a plus bi form? Not quite. We need to simplify this or split out this denominator. So now we're in the real a plus bi form. So on the test, am I that strict? Not really. If you leave it like this, it's fine. Just know that that is not quite the a plus bi form. All right, now let's have you practice. So go ahead and pause the video and try these 4 problems. All right, so please double check to see if you got the correct answers. So I did try to put everything in a plus bi form so you can see how I grouped these together, because if they're the same kind, then I put them together as if it's an a plus bi form. So you should probably do the same so that your numbers are not so like there's so many terms everywhere. You should try to group those same ones together. All right, so the last part on this section is to predict the quadratic solutions by the determinant. And what is the determinant? Well, quadratic, let's talk about quadratic. Quadratic means that the equation is in the form of ax squared plus bx plus c, right? Quadratic, remember, means second degree. So then if we wanted to solve this equation for its solutions, then we can use the quadratic formula. That will always solve every single quadratic equation. And remember, the quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. So then we can determine the solution by the determinant, and determinant is this part inside the square root. Sorry, not determinant, discriminant. So how do we tell what the answer is by the discriminant? Well, let's think about it. If this discriminant part is 0, okay, so if this part is 0, that means this part is all gone, right? Then how many solutions will you have? Well, you will only have a minus b over 2a. That means you only have one solution. So then we would say there's one solution. But what kind of solution? We would have a one real solution, because it would have to be a real number. Now, if this part, the discriminant part, is positive, if that part is positive, then how many solutions will you have? That means there's something inside the square root, and that thing that's inside the square root is positive, and so then the plus minus applies. Plus minus means there are two answers, and so we will have two solutions. Again, the question is, what kind? What if it's inside the square root and it's a positive number inside the square root? Then we would get a real number. So two real solutions. And then that comes to the last question. If inside the square root is less than 0, then what kind of solution will we have? Well, if it's less than 0, that means it's a negative number, and we cannot square root a negative number. That means we will have to use I, which is an imaginary number. So then there are no real solutions. Sorry, I don't know why I put 3 boxes. But there is a conjugate pair of imaginary solution because of the negative number inside the the square root. All right, so let's go ahead and have you practice these. So determine how many solutions it has using the discriminant, and then find the solutions. So I'm gonna do the first one really quickly because it's a much easier problem. Okay, so what we wanna do is apply the quadratic formula. So negative b plus or minus square root of b squared minus 4ac all over 2a. All right, so we just wanted to figure out how many solutions it would have using the discriminant. So let's look at that. 2 squared minus 4 times 1 times 5. So that is 4 minus 20. Well, it doesn't really matter what number it is negative. So then the first thing is it has two imaginary solutions. So really, you don't need the entire quadratic formula. You really just need b squared minus 4ac. Anyways, the next thing is it does want us to find a solution. So then we just kind of go through the problem. So negative 2 plus or minus square root of 4 minus 20. So square root of 4 minus 20, that is minus 16 over 2. So that is negative 2 plus or minus 4i over 2. That is negative 1 plus minus 2i. So negative 1 plus minus 2i are the solutions. Okay, so go ahead and pause the video and try number 2. All right, go ahead and look at the answer. So number 1, for this question, it has two imaginary solutions, and the second thing is that the answer is 2 plus or minus square root 15i. All right, let's go ahead and look at this next section. So P7. So this part you probably haven't really looked at it before, so this part is going to be a little bit tricky. All right, find the solutions to the following problem. This is a very easy problem that you've done before in, back in algebra. But we're going to look at it graphically, so then it might be a little bit kind of tricky to understand. All right, so the first thing is we have this part smaller than this part. Okay, so lagging a little bit. Okay, so this absolute value part is smaller than 8. Okay, what does that actually mean? So what it means is So I will show you on decimals since it's a little bit easier to understand, and then I'll show you how to do it on the graphing calculator. So remember, our problem is square root, absolute value of x minus 4 less than 8. So from before, I kind of talked about we can actually think of it as two equations, one on the left of the inequality and then one on the right of the inequality. So on the left, I have an absolute value of x minus 4. So I can think of it as y equals absolute value x minus 4. And then on the right, I can think of it as a y equals 8. And then so the question is, which part of this graph is, so which part of this absolute value graph is below the line 8 is the question. So which part of this graph is below the line 8? Well, that's pretty easy. It is this middle part, right? This middle part is below the line 8. Now, what are they looking for? They're looking for what x values on this red graph is below the line 8. Well, if you want to figure out where it is below the line 8, then you have to know where the two lines intersect, right? So then if you look at where they intersect, you can see there are 2 points, -4, 8 and 12, 8. So the question is asking for which x values, between which x values or which x values total is the red line or the red graph, which is absolute value x minus 4, below the line 8. So we already said that is this middle part. And so what two x values would that be in between? -4 to 12. Okay, between -4 to 12. So then let's kind of come back to our notes. So graphically, if we think about it, we are looking at two graphs where y equals absolute value x minus 4 is one, and then y equals 8 is the other one. So y equals 8, let's just kind of pretend it's up here. Oh, let me put it a different color. And then let's say that x minus 4, which is this one. Sorry, terrible drawing. Is this one. And so which part of this graph is below the green line? That's going to be here. And that is what? That is between these two x values. And then from decimals, we know that this is -4 to 12. So then we can say that the solution is between -4 to 12. Do we include the 2 points? No, because less than. It's not equal to. So we're not going to include the 2 endpoints. Okay? Now, algebraically, we already know how to solve this. What we do is we split it into 2, right? So we rewrite the problem without the absolute value as is, and then we rewrite the problem, but this time we're going to change it to a -8, which means we have to change the sign. Okay, so then we solve this. So x is less than 12, and then x is greater than -4. And you can see that it is the same answer. All right, so let's go ahead and try the same problem again. This time it's a greater than. So that's pretty easy, right? It's just the same problem, except this is greater than. So we have the exact same graph, but this time it's asking where is the red graph above the green graph, right? This represents the red, this represents the green. And so pretty easy, we're gonna say this part and this part. So how do we write that? Again, we got to know where they intersect. So that intersects at -4 and 12. And then how do we write numbers that are less than -4? That is x less than -4. And then how do we write numbers that's greater than 12? We write x greater than 12. Okay, and then algebraically, again, we are just going to solve it that same way. So rewrite the question, and then rewrite the question, except we're going to put a -a, which means we switch the direction of the sign. So x greater than 12, and then x less than -4. Okay, same answer. Now, let's put in everything we have learned this chapter. This chapter, we learned how to write in interval notation. So let's write all our answers in interval notation. So from -4 to 12, we will write parentheses, -4 to 12. In here, x less than -4, we will write -infinity to -4, parentheses, because we're not including it. And then x greater than 12 means from 12 to infinity. Okay, so from this point on, I would like to see more interval notation than inequality form. So try to kind of practice so you can get much better at this. Okay, let's go ahead and try to solve these graphically only. All right, so let's look at this problem. X squared minus x minus 12 greater than 0. So we're going to do this graphically, and we're going to write the answers in interval notation. So kind of think about how this problem is a little bit different from the previous problem. In the previous problem, we have like a absolute value, and inequality, and a number. Versus here, we have something like a equation, it really doesn't matter what it is, inequality, and then 0. So the key is 0. So what does 0 represent? All right, so this side means y equals x squared minus x minus 12, right? This is kind of the graph on the left. Now, what does y equals 0 represent? That is the x-axis. So it's much easier to compare a graph to an x-axis than to like what we had before, like a y equals 8. So then what I'm trying to say is that it's much better if you were to change every problem so that one side is an equation, the other side is always 0. So then it was much easier for us to graphically solve it if we were able to actually minus 8 on both sides so we can compare to 0. And I'll show you that on decimals and also on graphing calculator. So that's what you should do from now on with every problem. If you were not to solve it algebraically, of course, leaving it 8 is much better. If you were to solve it out graphically, you should always make it equal to 0 or compare to 0. That way you're always just looking at the x-axis and not something else. All right, let's show you how to do this with decimals first. So on one side, we have y equals x squared minus x minus 12. The other side, we have 0. And the question is, which interval is this graph greater than 0? So we know 0 is this x-axis. So where is the graph above? Again, that means we need to figure out where they intersect. So this graph intersects the x-axis at -3 and 4. So where is the graph above the x-axis? That would be on the left and on the right. So that means on the left of -3, on the right of 4. So that means numbers less than -3. And if you write that in interval notation, it will be -infinity to -3. And then on the right, that means from 4 and above. So that means 4 to infinity. Back to here. Okay, so this question, we would say, so the graph kind of looked like this. So where is it higher than the x-axis? Here and here. And so that is -3 here on this point, and then 4 here. So we would write it in interval notation, -infinity to -3. Remember, this is a greater than symbol, not a greater than or equal to. So we don't include -3. And then we say it is 4 or greater. So 4, again, not included because it's not equal to infinity. And then since we're talking about two sets of numbers and we are saying that both of them are valid solutions, we would write union in between just to say that the two sets are both this one or that one. All right, so let's try number 2. So again, like I kind of said before, you should always make it equal to or compare to 0. So do it like this, and then put it in the graphing calculator or decimals to check. So now I'm going to show you how to do this with a graphing calculator. All right, so graphing calculator. So what you're going to do is first we change the equation so that it is compared to 0. So we're going to type it in. So open up your calculator, and then what's going to happen is you would click y equals. Y equals is where you would plug in all your equations that you're trying to graph. All right, so we're going to type in 2, and this button here is the variable button. So if you press that, it would just be x. And then we want a square. Square button is here. So you can press that to get a square, or you can press this sign that's above the dividing sign, and that would become an exponent. So either way is fine. Okay, squared. And then we say plus 3x minus 20. Okay, now we're going to graph it. So we just click trace, and you should see a parabola. If you don't see the entire parabola like I am not seeing right now, you can click zoom, and then you can try a few different things. So I usually just stick with 6. Oh, I'm sorry. Okay, sorry about that. That program shut down on its own. Okay, 2x squared plus 3x minus 20. All right, trace. So what I usually do is I go to zoom 6 for standard, and it's the same one. And if you don't see everything, there are a few things you can do. You can always zoom out. So zoom 3 is zoom out. And then you have to click enter. So right now it's saying that the coordinate is centered around 0, 0. And so if you center at 0, 0 and say zoom out from 0, 0, you can see the parabola better. But it makes the parabola really small. So there's another thing you can do is you can go to window and then just change what you think, what you want the minimum and maximum y and x axis to be. So then you can see it better. You know, you can change it to anything you want. If you do want to use the negative sign, make sure you use the negative sign right here. This on the bottom next to the decimal, and don't use the minus sign because it doesn't like using minus sign as negative. So anyways, I'm going to put -10 to 10. Hopefully that's better. And then minimum, I don't think this parabola goes down that low. So maybe -5 to, I don't know, 10. We'll see. All right, not low enough. So let's change it. Maybe -15. Let's see if it's better. Okay, kind of better, but yeah, so you kind of get an idea. So what we're doing is we're trying to figure out where the parabola is below x-axis. And so we know that it's going to be here and here where it crosses, right? So it's, so the the part of the parabola that's below the x-axis is going to be in between those two intersections. And so the question is, what are those intersections? And you got to use the calculator to help you find that. So what you're going to do is click a second, trace, and then we're going to say find the 0. So the 0 is where the parabola crosses the x-axis. So there are 2 zeros, so I'm going to have to find one, each one by itself. So left bound is the first question. It's saying what is the bound on the left that encloses your first 0 that you want to find? So let's say I'm trying to find the one on the left. So I'm going to kind of keep going, and then you can see my cursor is going up. So I am now on the left of my 0, because my 0 is right on the x-axis and I'm slightly above the x-axis, so that's what they call left. So how left do you have to be? So do you have to be here or here or here? It really doesn't matter as long as you're on the left of it. So I'm just gonna leave it here. It doesn't really matter. Then I click enter. Then it's going to think that is the left-hand side of your bound. Now it's going to ask you, where is the right-hand side, right bound, meaning where is the right-hand side that encloses the 0? So remember my 0 is right here, so I want to be on the right of it, which it means just below. Okay, so this is pretty good. I'm right below that 0. So I click enter. The next thing it says guess, meaning can you tell me where you think it is? It really doesn't matter, just click enter again. All right, it tells me that the 0 is at -4. So that point here, right on 0 is negative, x-axis is -4, because you can tell it says y is 0. You have to let the calculator calculate it for you. Please don't just like click, 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 and then try to see like, oh, it looks like y is really close to 0, like 0.1. That is not 0. So let the calculator calculate it for you. All right, so we know on the left-hand side, the intersection is at -4. Let's look at the right-hand side. So 0 again, go to the right-hand side. Left bound. So I want to be on the left of the 0. That is right here. So I'm slightly below means I'm on the left. So enter. So you can see there's an arrow there that tells me the left bound. Right bound, so I'm slightly above. And then it has that arrow saying, okay, your 0 is stuck in between. Guess, just press enter, 2.5. So on the left, I have a -4. On the right, I have a 2.5. So I know that this graph is below the x-axis right here. So between -4 and 2.5. So this one is between -4 to 2.5. Remember here we have a less than or equal to, so that means we're going to include the 2 endpoints. All right, that's a lot of information, so let's go ahead and have you practice. So we're gonna skip the algebraic one because you can just solve it. Let's have you practice solving it graphically, and you need to answer in interval notation. So pause the video and try the first one. All right, this answer is -1 to 0, union 1 to infinity. Did you get that right? All right, let's try number 2. This one. Go ahead and pause the video and give this one a try. So the answer is -infinity to -5, include union 0 to 6. So the question is, where is it below or equal to the x-axis? All right, number 3, pause the video, try this one. All right, this one's a little bit tricky. This is no solution. And then the last one, x squared greater than x. So remember I said you need to, whoops, change this. If you don't, it makes the problem really hard to solve. So go ahead and try this one, pause the video and try it. All right, the answer is negative infinity to 0, union 1 to infinity.